Hello friends, today I am going to show the how can we predict any data with the help of ANN toolbox in Matlab. Okay, let's begin. This is, as we know already, this is the command window for the Matlab and this is the workspace. Now we can import any data from in the workspace. Let's start. In the workspace, first of all, make it two variable. This is input and make another new variable and name it as a target. Okay, now let me import data from my Excel sheet. Here you can see I classify this data as input and this is the output. This input data now I can import in the input variable in the workspace and output data as a input as a in the target variable. Okay, now copy the input data and just directly paste on the input variable then Matlab environment. But in case of Matlab, we have to make the transpose because Matlab cannot run this data as it is. So we have to make it a transpose matrix. Okay, close it. Then go to the target. Same as earlier. We copy the output data and simply paste on it. And earlier we have to make this matrix as a transpose. Just close it. Now this data input and target data is ready to use for in the ANN toolbox. So to call that ANN toolbox, we just put the command in the command window like ANN tool. Just pop up the ANN toolbox. You can see the input, our target, and network and output. The input, we just import the data and save in the workspace. Input, import data and import the target data in the target workspace, as you can see. Now we make the new networks and you can give the any name. As I am taking the data from the EDM problem, that's why I given the name as EDM. And you can see that in the network type we use the feed forward backdrop. We can use any kind of network type as according to your problem. Okay, next the input data. In input data we select the input in the target as the target and training function. Also we can use the any kind of training function depend on your problem. And adaptation learning function is learn GDM is by default. can give. And the performance function, we can use the MSC, mean square error. Here we can use the two layer. The number one layer, we use the 10 neurons and make it 14. You can change it as per trial and error basis to make your problem more close to the fit. And the transformation is transit. You can view the network here. This is the network. In is input, we take the 4 input, and in output we can is the 3 output. 4 input, 1, 2, 3 and 4, and 3 output. Create the network data. It's already created. Just close it. Now just click on the network, EDM network. In the EDM network, we can take the same as a input data here and target data, and now train the network. Here you can see in the this is the network we created earlier, and this is the data division. Random training is 10 LM, Levenberg, market performance is mean square error, calculation is Matlab. Here you can see the epoch. Epoch is the number of iteration and the time taken, the performance gradient and variation checks. We check the performance plot here. In the performance plot, you can see my training graph is in descending order, which is first required or desired in my problem, because descending means mean square error is low. Okay, and same we can check the regression. The regression, we can see the problem is training R value is 0.99, which is very much with the value of 0.99 means my problem is accurate. All the validation test and test all are in 0.9. This is very good. The nature of this data is very good. If if you cannot get the R value is near to 0.9, you can change the training parameter here. Let me expand the window. In the training parameter, we can change the epoch, number of epoch, then number of maximum fail, we make it 100. NU means learning function, learning rate. Now again we train the network, and let me check what is the nature of the regression. As you can see, all are in fit with the data. It means your problem in the in good fit. Let me check the performance also. Yeah, it's fine. You can see the best validation performance is 1.4662 at epoch 1, means in the number one iteration, it goes to the best validation performance. Okay, Here we can change another thing. We can change the weight here. You can change the weight, revert weight, initialize the admin weight, then set weight, train, again training the network to check if there are any changes. You can see. Yeah, it's near to the one. I think this is accepted for the problem. It's 0.99. Okay. Now let me find out the prediction value. Prediction value. We can check the prediction value in this window. Is output. We have output. Yeah. So you can see there is a three row. In the first row, this is the prediction value for the my number one output, and second row is for the number two output, and third row is for the number third output. Okay. Now we can export this output value in the workspace. Export workspace. Yeah, you can see here the target value has come. This is the predicted value by the ANN network. This is for the number one. Copy. Paste here. Yeah. To paste here. Sorry. Yeah, you can see in the up to the 40 there is no change. I think. Let me expand. Some no changes. The actual value and the predicted value. Yeah, in this way you can find out the predicted value here. Thank you very much.